Hello everyone. This session we discuss about trigonometric function. One special one is inverse trigonometric function. The inverse, we say that we can look at this definition. In fact, the sign is y equals to sine x equal to -1, right? Or the simply we just say y equals to arc x. What's that mean? When here y here in fact is the angle or is the radius theta. If the y sine y equals to x, then we made what? We made y equals to sine x over -1, or y equals to arc sine x. So this y equals to sine x -1 is the inverse function of the y sine y equals to x. Okay, so they have some kind of circumstance. If we call inverse function, then both their xy, after they change, their domain will never change. So look at here, the x is a number, right? X is a result. So x belongs to -1 to 1. They are bracket, so they will increase, right? They will include in -1 and 1. So y will belongs to the angles, right? Radius. So they will be from -pi/2 or plus pi/2. Okay, here they have a thing. If the y here is over pi/2, such as like a 3 pi/2, then what are we supposed to do? We cannot make this one, right? So what we're supposed to do is we have to find the same result of the sine y that in the domain of the -2 pi and the pi/2. Just give example. Okay, okay, how to say that? 1/2. Okay. Like sine -1/2, right? So this is equal to y, but this y can equals to what? Pi/6, right? Pi/6, right? Okay. Can we also make it like 7 pi/6? 7 pi/6? Yes, can, right? But since the domain here is the -pi/2 and the pi/2, so we cannot this one. So we only can choose pi/6. Okay. Yep. Anyway, I'm just give example. I'm not so sure this is equal. Okay. Okay. Let's just see next example. That next y equals to cosine. Just now is the cosine. So the inverse function is y equals to cosine x to the -1, or y equals to arccosine. The domain is a little difference. The x is same, but y equals to 0 to pi. Sine is -pi to 2 pi. Okay, remember this one. Now we do 3 exercises, and then we do a hard exercises to remember this one. Okay, so first exercise is y equals to, I can say y equals to, okay, sine -1/2 to the -1. So we also can call it arcsine -1/2. So what's that mean? So in fact, this is what? In fact, this is one find the y, right? One find the y, and the y, or we can go data, right? It's an angle, right? It's an angle, is a radius. So how we count this one, right? How do we count this one? Okay. So first, this is a -1/2. So this in the range of -1 to 1 because it's sine, right? Okay. So -1 to 1. So the corresponding domain will be what? -pi/2, right? over pi over 2. Since this is negative, so this should be belongs to 0 to negative 2 pi, right? Okay, so we learned before they have some special, they have several special angles. We learned that 30, right, pi over 6, or and 45-degree pi over 4, and somehow this is exactly as 1/2. 1/2 is exactly is pi over 6. So since we remember this, we can write in as the angle will be y equals to what? Y equals to negative, right? Pi over 6. Okay. If you want to recall why -1 is pi over 6, remember. Let me draw. Okay. This axis, this is y-axis, this 30 angle. Okay, this is the one in the circle, right? P. Remember? So this one. So this is a sine x equals to y divided by r, right? Right? Divided by r equals to 1/2. The negative 1/2 just mean what? Just mean the y is go to the negative 30, right? Just mean this one, but their height are the same, right? So it's this one, right? Yep. Remember this one. Uh, if the another side is 1/2 the hypotenuse, their corresponding angle is 30 degree. That's we learned before. So now I'm here is writing is negative pi over 3. That's also prove me this is a negative angle, right? Okay. So how about the second one? Sine. This is interesting. They have two. So what's this look for? Sine. Then sine inside should be the angle, right? Should be the angle y, right? So, or theta. So and the lay should come out with the result. Am I right? Should be result. But here the sine -1/2 to the -1. This already provided your result, right? The result is -1/2. So you just write in -1/2. Just to make sure it's -1/2 is in the domain. It's -1 to 1, right? It's in between. So it's right. Okay. So another example, quite simple. So this one, I already know the answer, -1. Am I right? Okay. This compare little hard. Let's observe it first. Okay. In fact, I drew the previous lesson that we learned about because this is a kind of the two cosine 2 sine, right? ArcSin and -1/5. This one after 2, this one should be an angle, right? So if it is angle times 2, so we can uh, look at the previously what we learned, the two angle, double angle, right? So we can here, in fact, we can write in here is same as cosine 2a, right? Then based on formula equals to 1 minus 2 sines what? Sines a square, right? Am I right? What's a here? A is sine -1 and -1/5. Am I right? Am I right? Okay. Since this is not a special angle, so I cannot immediately say what's this angle it is. So I cannot say what's the A is which angle. I cannot say. Okay. But the good things we don't necessarily need to find the angle. We just need to find the result, right? We need to find the cosine 2a, right? Cosine 2a. That's what we need to do. Okay. But here, we already have the sine. We already have the sine a, right? We already have sine a. Am I right? Sine a is what? Sine a is what? Sine a is -1/5, right? So let's just write in sine a is -1/5. Okay. So since we know that, we already know what's the cosine 2a. So cosine 2a is equals to 1 minus 2 times sine a square. So 1 minus 2 times this is square, negative 1 over 5 square. All right. So is equal to what? 1 over 2 over 25. So 23 over 25. All right. So yeah, so we finally simplified to the final answer. You think about that, if we don't know the formula of double angle, this kind of the result we will never can draw, right? Because it's so hard. It's not specific angle. Okay. So today we just introduced the inverse function of trigonometric of the sine and cosine. In fact, they also have what? Also have tangent. You can learn that at the end. I think a similar one. Uh, What's another part I did not introduce is their graph. Is their graph, but since I already introduced graph before, this one just the graph, the shape is totally different. It's not y equals to arcsine x is totally different from the y equals to sine xy because their domain are totally reversed already. So the graph is totally different. But remember, some did not change. Like what we learned that if x minus 1 is moved to the next side, right? If y plus 1 is y move 1 up, right? So those never change. So I just simplified that one. Okay. So thank you very much to join this session and hope you have a nice day. Bye bye.